Hey everybody, my name is Julius. Welcome back to Fastware. I know it's been a very long time and I do apologize, but I'm back and with a new project which I hope you'll be interested in. Let me know if you are. So what I decided to do is build up a little OpenGL framework with a few systems to allow logging and memory allocation, which we've done in the past, and I will leave kind of a little cards in a corner if you want to follow these. So we have a little earth, a little spheres with a texture wrapped around it, and the coloration comes from the normals, which I will try to explain in detail. I mean, I'm not a graphics developer, so bear with me as I struggle along. Maybe not everything is going to be clear, so I'll try to leave people who do OpenGL sort of for real. I'll leave links to like OpenGL Learning and other YouTube channels who actually demonstrate and can explain this much better than I do. But what we'll try to do is build up maybe a little game, like a little tower defense game where you can have maybe tens of thousands of enemies coming at your tower and you need to defend it. You build, thousands of, or at least 1,000 maybe of your defensive structure. So there will be a lot of data to transform, a lot of visual effects to implement. So I think it will help us stress test systems that I was demonstrating in the past, how to build like a memory allocation system. I have comments for to demonstrate how to implement high performance logger. So that will be another one. There will be a dispatcher, which there was a comment as well asking for that. So we will try to build up these sort of systems to demonstrate how they can work in the setting of a realistic application rather than just putting it through the benchmark. Because I thought that was a little bit lackluster and it didn't kind of give you a good feeling of how it will actually integrate in a proper system. So here is what I'm trying to do now. I hope you will kind of come along on this kind of a project. I'll try to upload every couple of weeks, though I'm probably not gonna succeed every couple of weeks, day job, family, all that stuff. So bear with me. But if you will want to take a project into a specific direction, let me know. If you want to contribute, let me know as well. That would be really good. Because again, as I said, I'm not a graphics developer and I'm not a 3D modeler. I don't know how to do these things, at least well. So I'm sort of an amateurish, self-taught, played around with different bits and bobs. But if you are, help and at least suggestions would be greatly appreciated. So without further ado, let's dive in and demonstrate a little bit about how this thing works. This is just an introduction. As you saw, a little demo. We'll be taking this further next week with basically expanding our systems and building up this sort of a game. It's not a game engine series because I don't know how to do that. Again, not my kind of a forte, but I think the graphics applications allow for a lot of data to be transformed and stress testing different systems, which I do care about. You already know the memory allocator. It comes from memory allocator series. If you haven't seen that, check it out. The card will be in a corner. So currently we have the stack allocator and the pool allocator, but we will need to expand these to include maybe block allocator or some other systems. As we will come along, we will see what we need, so we'll build these. We have a very, very primitive logger, an atomic double buffered logger, which basically, while you can write into a log using during the frame, at the flush time, it spawns a thread, which basically currently it writes to standard out, but it could basically write to anything. right, to a file or any other place. Even if you want to render it on a screen, that could be probably possible as well to do. So this is the basic double buffer logger. We'll be expanding it and building kind of a more sophisticated systems to allow this sort of a threaded behavior. Currently, it doesn't do that. It just flips sort of the one buffer for another and flushes it out while the other one is being written. What else do we have? We have a couple of systems with clock, with file, dealing with string hashes, basic math bits, and some types for user input, textures, and other bits. So just a lot of enums, which is nothing particularly interesting. The render includes the OpenGL bits and some image stuff, render state, camera. Probably the important thing here is that I like a declarative workflow, at least for OpenGL. As I was learning it, I found it to kind of suit me most. Let me know if you like it as well. It allows you to basically create, well, let me actually demonstrate. These sort of things where you declare how your data is structured rather than basically writing it directly into buffers, saying, oh, my data is structured that I have vector of 3, vector of 3, and vector of 2, and then that buffer will be basically section of vectors of 3, section of vectors of 3, which is going to be first going to be the positions, then it's going to be your normals, then it's going to be your v. So this is the data that this sort of a buffer section definition represents. And then, so this is for each vertex, so for each kind of a point for a triangle to be rendered, this is the data that will be provided. And then we have a per instance data, which is the 4x4 matrix, which is the model data. So the position, rotation, and all the other bits about how that model needs to be transformed, right? Then when you're creating your kind of a vertex buffer definition, you say, so buffer 0 will include this per vertex data, right? And there's 3 bits here. And then the second thing is in the buffer 2, you will have the per instance data. And then the buffer 1 includes the indexes. The indexes, as far as I understand in OpenGL, is something that allows you to deduplicate vertex information. So if you can imagine, you have 2 adjacent triangles. Each triangle has 3 vertices. In order to draw 2 triangles, you need 6 vertex information, but because they are adjacent, 2 of the vertices are shared between those 2 triangles. So in order not to duplicate all that data, you can use an index saying you only provide 4 vertices and then 6 indexes to tell you how to access that data. Because per vertex information is a lot bigger, so you have again the position, the normal, the UV. Later we can probably add a lot more, like a visual effect. I'm not even sure. I'm not a graphics developer again, so I know that at least to render something with a texture, I need at least these things. So indexes allow us to deduplicate information. So obviously we need to create our, for a 3D application at least, we need to have a view where your camera is looking at and the projection. So basically as a 3D, you know, things are going from kind of a big upfront to getting smaller, as they are further kind of in the scene. So this is what the projection matrix allows us to do. We have a buffer update info, which is for these models. As you remember, you have those spinning spheres in different positions. So the update info facilitates to do that. Where basically we are able to transform these and tell that so this model data in a buffer 0 needs to be constantly updated. So this is that per instance buffer And in our main render loop, we keep updating our models, and then we telling the this buffer to be written from the CPU to the GPU. We also have some things like uniforms, and we need to bind our textures and samplers and whatnot. I will leave a bunch of kind of things in a description for OpenGL, how to do these things, because I just thrown them together and I don't know if my explanation would make sense. I would much rather leave it to somebody who's more experienced with OpenGL to explain these things to you than me. But what we will be focusing on is building these core transformation systems, you know, the logger, the dispatcher, the geometry manipulation, kind of systems, the game systems themselves for, you know, your enemy's life. They're maybe if they have some armor or they're carrying a shield or they have some energy shields, or you know, whatever other bits maybe we need for the game itself. So all these systems that we will need, we'll be building them and make sure that they're high performance and our game can handle loads and loads and loads of enemies. So, you know, it will be a lot of fun to do this sort of thing. So main render loop is currently very simple. We don't have any sound or anything else. No particular visual effects or particle effects, which we probably will maybe try to build. I never built it before. So if you know how to do that and you want to help, your help would be greatly appreciated. So with that, again, if you want to see this project come to life, leave your likes. Let me know. Subscribe if you want to follow the series. Check out the GitHub, which is going to be in a description for this rudimentary implementation that I have currently. Yeah. And with that, have fun writing fast code. Cheers. Bye.